Okay, in this video we are going to discuss about algorithmic strategies. So algorithm already we have discussed in the 11th standard. There is step by step process to complete a task in our own language. There is idea, that's all, to complete a task, that is called an algorithm. So there is number of strategies we should follow, number of characteristics available while writing an algorithm, and after completing an algorithm, is a good algorithm or not, that measurements, how to measure the algorithm, and then some examples of algorithm, sorting and searching. Some examples we are going to discuss in this chapter. This is chapter 4, algorithmic strategies. So algorithm, already told you, an algorithm is finite set of instructions to accomplish a particular task. So finite set of instructions that should be in step by step in correct order. That is important. It is a step by step procedure for solving a given problem. That is called an algorithm. So while writing an algorithm, so whatever the process we are trying to do in real time or in a computer, there must be an input. So without input we cannot able to do anything. We are giving some, if I'm giving to something, you means using that only you can do anything. Without giving a 2 numbers, can you add a 2 numbers? It's not a possible. I should give a 2 numbers to you, then only you can perform process. So first, every algorithm there must be an input. Algorithm must have an input and output. So we are giving input for some getting some outputs only, right? And in between what happened, we are giving input, we are giving raw material, finally we are receiving something. In between what happened, there is a process. So this is basic algorithm: input, process and output. That should be in this order. And then while writing these 3, input, process and output, there is some characteristics are there. Here 3 only explained here. In the next page we are going to discuss there is 11 or more than 11 characteristics they given. While writing algorithm, we should consider the characteristics. See here characteristics such as definiteness, there is exact result what user is expecting, that should provide your algorithm. Correctness, there should not be any mistakes in whatever the situations. Effectiveness, if that should be usable to the user can do that in their manually, but we are creating a software, means that is not an effective one. They can't do their manually. Then for what software? They won't prefer our softwares. We are wasting our time, right? Okay. So these are the characteristics. Not only these, some characteristics are that we are going to discuss. So data maintained and manipulated effectively through the data structures. So data structures, there is a number of data structure concepts available. That is retrieving a data, arranging a data, storing a data. See searching to search an item in a data structure using linear or binary search. Leave linear or binary search later, we are going to discuss. Searching in finding something from the existing one. There is group of data are available, there we are searching our desired one. Sorting, arranging the data either in an ascending or a descending order. Then insert, there is group of data available, in between we are going to insert something. Update, it is either inside or at last we are adding something. Delete, to delete an existing item in a data structure. So these are some ideas, some process while we are writing algorithm. Searching, sorting means that meanings we should know. So the definitions given here. Then the algorithm. The way of defining an algorithm is called algorithmic strategies. So algorithmic strategy means way how we are defining an algorithm. That method is called as algorithmic strategies. So this algorithm concept is introduced by the word algorithm, comes from the name of Persian author Abu Ja'far Muhammad ibn Musa al-Khwarizmi. So from this person introduced the algorithm. He is a mathematician. So here characteristics of algorithm, already I told you, input and output. For that purpose of performing some task only we are doing, we are creating some ideas, right? So input, there must be an input, 0 or more quantities to be supplied. If we give something, then only whoever our machine that will respond to us. Then output, at least one quantity is produced. Then finiteness. Algorithm must be terminated after finite number of steps. There should not be a more steps to complete a task. Take example, you are coming to school. There's multiple ways available to reach a school. Which one you will prefer? Which is the shortest path? That one only you will prefer. So there is finiteness, definiteness. That is exact. Definiteness means exact. Our algorithm should provide exact result what user is expecting. Then effectiveness. Every instruction must be carried out effectively. We are writing we are completing a program. Okay, take example, we are preparing a coffee. Okay, so we are taking tea powder in our table, means is that is an effective one? It's waste, right? So like while writing program also, unnecessarily we should not take a data into our program. What we need, that only we need to take. Then correctness. Algorithm should be error free. So error free means you all know very well. In the last year, 3 type of errors we were discussed: syntax error, semantic error, and runtime error, right? So while writing algorithm, the error should not, without error our algorithm should provide an output. Correctness, the algorithm should be error free. Then simplicity, easy to implement. So in number of ways we can create a coffee or whatever the process. That should be a simple one, then only user will prefer. Already I told you an example, which is shortest path to reach a school, that only we will prefer. While coming time also, by walk, by bus, by bike, so which is easiest one, we will prefer that one. Right? So we should follow these all the characteristics. We should there must be an input and process, then output. Here 2 examples given in our book. The procedure for preparing coffee is as follows. So take a bowl, water, and pour into the bowl. Then filter it, boil the milk, mix sugar, and filter coffee along with the boiled milk. Pour the coffee into the cup. So this step-by-step instructions that require to complete the task that is complete is of preparing coffee. One more example given here: designing algorithm for squares to get a square numbers. Given a number displays the result. Algorithm to find the square. So for the first start the process, get an input x, calculate the square, and displays the result. Right? So an algorithm that is expected output, what we are expecting, that output we will get, means the valid input is called an algorithmic solution. So what we expected, we decided to prepare a coffee, and finally we got a coffee, means there is an algorithmic solution. We planned to prepare a coffee, but finally we got a not a coffee other than a coffee. There is means it's not a good algorithm. So while I'm explaining, I use the word algorithm and program. So what's the difference between algorithm and program? So algorithm is our idea. Program is using computer programming language. We are writing step by step codings based on the predefined structure, based on the language, computer language. So see the first one, algorithm helps to solve given problem. Yes, solve the given problem logically, and it can be contrast with the program. Yes, it solves the problem. We have an idea, but for what computer, for what we are entering into the program, that is programming in a computer. So for reduce the time and spaces. Take example, nowadays in 500 MB we are downloading movies. Size is very less. Right? So in computer, 100 members they are working manually, means the 10 members is enough for doing the same job in a computer. So already number of exams I gave in classes, that is in a Discovery Channel, food factory. Everything in food factory, everything maximum works are done by the robots. Okay. So this is the program. Program is an expression of algorithm in a programming language. And then algorithm can be categorized based on their implementation methods, designing technique. That is idea of idea. Program is based on the In a programming language, three type of structures we were discussed in C++. You know very well, there is structure oriented programming, object oriented programming, then modular programming. There's these different type of programmings are available in a programming language. There is no specific rules for algorithm writing, but some guidelines should be followed. But in a programming language, depends on the programming language. There is some syntaxes. You know, syntaxes mean there is predefined rules and regulations, but structure, the same structure we should follow in a programming language. It depends on the program syntax. Then algorithm resembles a pseudocode which can be implemented in any language. So algorithm is an idea. Actually, algorithm is the first one our idea. We are writing in our own language. The next level process is writing a flow chart. And the next one is a pseudocode. The next one is a program. The fourth level only a program that is more specific to your programming language. Then analysis of algorithm. So before starting to write an algorithm, we should do an analysis. So what input, what task is this? And then what is the first step, what is the second step, what is the third step after completing the program? And this is the performance of our algorithm. These are all the things we should estimate before start to writing an algorithm. And after completing an algorithm, we should apply in our real time. And already we analyzed, and after now we completed. Now apply that one in real time, and we will get some output. And compare before analysis and now after developing analysis. It's same or different. So this analysis is important. Whatever the algorithms we are developing. See here, the priori estimates and posteriori estimates. Priori estimates. This is the theoretical performance analysis of an algorithm. Efficiency of an algorithm is measured by assuming the external facts. Just assuming. We are not working and finding output. Just we are assuming for this step. If we follow these steps, we will get this output. Theoretical estimation. Now next one, posteriori testing. This is called performance measurement. This one is a analysis, performance analysis. This one is a performance measurement. Yes, after developing an algorithm, we are doing practical. While doing practical, we know very well how many times it takes for completing the task and what are the resources we used, right? So that and all we are practically we are aware. So that is posteriori testing. Right? Performance measurement in this analysis, actual statistics like running time are required for the algorithm execution are collected. So this analysis, an estimation of the time and space complexity of an algorithm for varying input sizes is called the algorithm analysis. So you develop an algorithm for addition between two numbers means you are giving input values 2 and 3. You got a result 5 weeks, immediately you should not stop. Our algorithm is correct. We should not conclude our algorithm is correct. We should pass different type of values for A and B. For all the input values, our desired output we got means. So that is algorithmic good. So there is a good algorithm, there is algorithmic solution. So this we are passing different inputs and checking this process is called as algorithm analysis. It's called the algorithm analysis, an estimation of the time and space complexities for an algorithm for varying inputs. So it is enough for this video. We will continue in the next video. Thank you.